Make sure that comes back on. All right, here's the next thing you should always look for when you're doing these. If you don't have a greatest common factor, or even if you do, if you have a difference of two squares, you're not going to look for this one. But here's what you should always look for next. Always look for perfect square trinomials. I'll make that an A here if I can. All right, so always look for those. Trinomials means how many terms? 3, okay? Here's an example of one that we'd work with. X squared minus 6x plus 9. Now, when did we use these in the very close future? We just did it a couple days ago. We used it way back with circles. We use perfect square trinomials when we're working with completing the square. So if you can do completing the square, you've got this part done. Because here's how you know if it's worked. For a perfect square trinomial, your first and your last have to be perfect square numbers. The difference is, when you have a difference of two squares, you get two different signs. When you have a perfect square trinomial, you get two sets of parentheses, but they have to be the same sign. How do you know which one to use? Well, this tells me same sign. This one tells me if it's positive or negative. If it's negative, both of them have to be what? Negative. And your x would go here. What's the square of 9? What's 3 times 2? You know it works. So I go 3 and 3. Or could you write it, for those of you who like to do shortcuts, the quantity x minus 3 squared. Now how can you check if you're right or not? FOIL. And here's what I tell people. You pick the numbers to do the F and the L, the front and the last, perfectly. So just OI it. Do I go negative 3 times x plus negative 3 times x? Do I get negative 6x? So if you just OI it, you can always check yourself as an answer. Here's another one that's very similar to this. How about if I go x squared plus 8x plus 16? Is that a perfect square trinomial? Yeah. If I do, here I got the perfect squares. So I'm going to try this, if nothing else. Oh, same sign, both what? Both positive. So I get x plus, what do we go? X plus what? Quick check. Outside, positive 4x. Inside, positive 4x. Do they add together to be a positive 8x? You're perfectly factored. Time saver. Yes?
So then if it was x squared plus 8x minus 16, then
Does not work.
also we can do.
It's not a perfect square trinomial. To be a perfect square trinomial, you have to have plus at the end. Otherwise, it's nothing. But notice, how do I get this? By squaring a what? I squared the binomial to get it. And if you're squaring binomial, it will always come out to be positive at the end, because a negative times negative is positive, or positive times positive is positive. Yes, remember.
So how do you know if it's a perfect trinomial?
How do I know? First of all, what the sign is. If that's not a plus sign here, throw it out. It's not a perfect square trinomial. But you have to have your first and your last have to be perfect squares. And if you remember, how do we do completing the square? We took the middle term and divided it by what? And then did what to it? If I took this middle term and divided it by 2, I got a negative 3. If I squared it, did I get a positive 9? Then you know it works. So kind of think of it like completing the square. Or if you can do it like this, if I can take the square root of 9, and I know it's going to be a positive or negative 3, if I double it, do I get that middle term? Is another way of thinking about it. Yes, ma'am?
So it's just basically the number that comes out of it.
It's really doing completing the square kind of in our head is really what we're doing. This right here is the reason why I can complete the square and write equations of circles. That's why you're going to be able to write the equations of ellipses or parabolas next year, is because of this one thing. Kind of cool. But is that the only ways that we ever factor? Wouldn't that be nice? No. If none of the ways work, of the above ways work, with the form ax squared plus bx plus c, then use multiply, add, choose method. Now this is the method that I've been teaching you all year. Or for some of you, did you understand Donald drill this? You know what I'm talking about? He was like totally obsessive with this. But it works great. When is this the best method to use? Anytime you have something more than 1 in front of your x squared. So an example of this would be the following. 3x squared plus 14x plus 8. Looking at that, first thing I mentally look for is a greatest common factor. Is there a greatest common factor? Obviously, not a difference of 2 squares. So that's gone. Is it a perfect square trinomial? No, because it's 3 ruined that, right? And then, of course, the 8 also ruined it. So I'm kind of stuck now. But remember, A is 3, B is 14, and C is 8. So then we put our little chart over here. This is my multiplies, okay? This is my adds too. What do I multiply together? Your A and your C. 3 times 8 is what? And we keep track of their signs. They're both positive. So it's a positive what? A positive 24, but adds together to be our middle term. So it's going to be what? Positive 14. Now, just, most of you can instantly do this in your head, so just chill for a moment, okay? What if you didn't remember? You start factoring. You go, okay, multiples. 1 times 24 is 24. That gives me 25. Obviously, not working. Then I go, all right, 2 times 12. All right, 24. Oh, does that add together to be 14? So that's what you choose. There's your C. So I choose those. Then I split my middle term. I'm going to actually use what's called factoring by grouping to do this. So I get 3x squared plus 2x plus 12x plus 8. Notice these are the ones it splits to. The 3x squared and the 8, do I touch? Doesn't that look like I'm in the middle of foiling? Basically what we're doing. Then you look at the very first 2 terms, my 3x squared and my 2x. Can I take out a greatest common factor just for that? So we get x times the quantity, 3x plus 2. That means when I look at this one right here, my plus 12x plus 8, I really want it to look like 3x plus 2. What would I have to take out if I want a 3x plus 2? Positive or negative, first of all? Positive 4. Excellent. So we get plus 4. Now, remember in our brain, this really is, the 3x plus 2 now becomes your greatest common factor. So now I can get my 2 sets of parentheses, because I'm going to take out my 3x plus 2. What's left? An x. There, it's factored. The cool thing is, multiply, add, choose works for a difference of 2 squares. You're missing the middle term, so you just make it 0x. You know, anything like that. Perfect square trinomial, if you go brain dead, it works. But the neat thing about multiply, add, choose, if I have something as simple as x squared plus, let's go 5x plus 6, if I do the beginning part, you really can skip the in between, because a lot of you see the pattern. My A is 1, my C is 6, so they multiply together to be a positive 6, add together to be 5. A lot of you are really good at this. What 2 numbers is that? Yeah, 3 and 2. They add together to be 5. So can I instantly, because there's a 1 in front of this, can I instantly go x plus 3 and x plus 2 and be done? So do I have to, when there is, basically, and remember this, if there's a 1 in front of your x squared, you shouldn't have to go through this whole long process. You should be able to go into your 2 binomials. All right, did this jar memories a little bit and hopefully review it a little bit more? All right, so let's work on your homework. Let's work with partners, okay? Let's try to get it done before you leave today. I would love that whole homework to be done and we can start working on our review packets.